A new analysis of global data shows apparent slowdowns in scientific disruption were artifacts of measurement methods rather than genuine declines. This is Planetterrian Daily, episode 150. The paper directly challenges a 2023 study that reported declining rates of disruptive discoveries across fields. Researchers attribute the earlier result to changes in how citation patterns and paper metadata were recorded over time. The new work reprocesses the same underlying datasets with corrections for those artifacts and finds stable or rising disruption metrics. The authors conclude that science continues to generate novel combinations at rates consistent with historical baselines. Follow-up work will test whether field-specific citation norms require additional adjustments. Now, shifting to a very different area of research. A 236-million-year-old specimen preserves pelvic and fetal structures indicating internal gestation in cynodonts. The finding pushes the origin of viviparity in the mammal line back tens of millions of years earlier than prior estimates. The preserved pelvic and fetal structures support the interpretation that the animal retained developing offspring internally until birth. The specimen provides the first direct fossil evidence that some cynodonts gave birth to live young rather than laying eggs. Additional specimens from the same formation are now being examined for corroborating anatomy. That deep time reproductive shift invites comparison with modern conservation genetics, where whole genome data now reveal hidden vulnerabilities in living mammal lineages. Whole genome comparisons across Asian elephant subspecies show large differences in effective population size and inbreeding. Populations with the lowest heterozygosity face elevated extinction risk from disease and habitat fragmentation. The analysis supplies spatially explicit priorities for translocation and corridor planning. Groups with the smallest effective population sizes carry higher loads of potentially deleterious variants, increasing their vulnerability to future stressors. The data allow conservation resources to be directed toward the most genetically depauperate populations rather than treating all groups as equivalent. The work also supplies a baseline against which future translocations or habitat interventions can be evaluated. Genetic health in large vertebrates depends on efficient molecular tools. Generative models produced complete bacteriophage sequences that assembled into replicating viruses. Several of the synthetic genomes yielded viable phages when assembled and introduced into host cells. The work marks the first reported instance of end-to-end computational design of replicating viral particles. The result raises questions about how quickly biosecurity screening can adapt to artificial intelligence-generated sequences. Follow-on studies will test whether similar methods scale to more complex eukaryotic viruses. Designing new biological systems at the sequence level parallels efforts to engineer useful properties into solid-state materials at the atomic level. Rice University researchers applied controlled uniaxial stringing to place an altermagnetic candidate into a single magnetic domain state. This configuration allowed direct measurement of the material's intrinsic spin transport properties without domain wall interference. Altermagnets combine aspects of ferromagnetism and antiferromagnetism, potentially enabling low-heat information transfer at nanoscale dimensions. The team's approach demonstrates a practical route to characterize these materials for spintronic applications. Next measurements will examine how domain stability holds under device-relevant temperatures and currents. Materials that move information with minimal heat connect to another carbon-based system now shown to generate voltage from mechanical strain alone. Rice University experiments demonstrated that uneven bending of graphene sheets produces measurable voltage without external fields. The effect arises from local strain gradients at the nanoscale wrinkles rather than uniform deformation. This provides experimental support for flexoelectricity in atomically thin carbon materials. Device prototypes could exploit the phenomenon for energy harvesting in flexible electronics. Further work will quantify efficiency across different wrinkle geometries and stacking orders. From engineered materials, we shift to engineered molecules, where soil bacteria are yielding entirely new chemical scaffolds. Helmholtz Institute researchers screened previously understudied soil myxobacteria and isolated 5 new chemical scaffolds with antibiotic activity. The compounds were identified through genome-guided extraction and activity assays against resistant bacterial strains. This expands the known biosynthetic diversity within the group beyond previously cataloged metabolites. The team deposited the producing strains in public repositories for further investigation. Additional species from European and Asian soils are undergoing parallel screening. New compounds often come from rapid environmental change. Colorado State University and partner analysis of recent Western North American fires found that spread rate predicts both burn intensity and post-fire regeneration failure. Areas scorched by the quickest moving fronts retained fewer live seed sources and shifted toward non-forest vegetation. The pattern holds after accounting for fuel moisture and topography. Models incorporating fire speed metrics improved predictions of forest recovery trajectories. Managers are evaluating whether early suppression tactics can alter speed distributions. Environmental extremes also appear in historical records, where compound events set benchmarks still unmatched centuries later. University of Liverpool analysis reconstructed the St. Mary Magdalene's flood using historical records and paleohydrologic markers. The event combined prolonged heavy rainfall with saturated catchments, producing peak discharges unmatched in the subsequent 7 centuries. The study highlights how successive extremes within a single season amplify impacts beyond single storm scenarios. Modern risk models are being updated with the reconstructed hydrographs. Similar compound event reconstructions are underway for other European basins. While large-scale environmental patterns are being clarified, smaller-scale behavioral patterns also shape health outcomes. Data from more than 58,000 adolescents across 21 countries showed strong associations between unstructured time and both delinquent acts and victimization. Periods lacking adult supervision or organized activities correlated with elevated risk even after controlling for socioeconomic variables. The pattern held across diverse cultural and economic settings. The authors suggest structured after-school options as one modifiable factor. Longitudinal tracking of the same cohorts is planned to assess directionality. From behavioral environments, we move to physical ones, where even microgravity produces selective rather than uniform effects on human tissue. Cardiac tissue samples from astronauts on the International Space Station showed no measurable decline in contractile force generation. The finding contrasts with documented losses in skeletal muscle and bone density under microgravity. Researchers attribute the difference to continuous mechanical loading from the heart's own pumping cycle. The study used engineered heart tissue constructs exposed to space conditions for comparison. Longer duration missions will test whether cumulative effects appear beyond current flight lengths. Selective resilience under extreme conditions also appears when researchers examine venom evolution rather than assuming standard defensive functions. Bangor University researchers compared venom composition and prey response across viper species and found no correlation between pain-causing components and predatory success. Instead, venom profiles align more closely with immobilization speed and metabolic efficiency against specific prey. The results suggest defensive pain effects are secondary rather than primary selective pressures. The team sequenced toxin genes to trace when pain-related peptides appeared in the lineage. Additional species from southern Europe will be added to the dataset. Most people assume snake venom evolved primarily to cause pain as a deterrent or weapon. In European vipers, however, venom chemistry aligns more closely with rapid prey immobilization than with pain induction. Right now, as you consider the next time you encounter wildlife safety advice, the relevant distinction is between defensive display and predatory efficiency. Researchers found that toxin profiles correlate with metabolic cost and prey handling time rather than nociceptive potency. One memorable detail is that pain-causing peptides appear later in the evolutionary tree and do not track hunting success across species. The practical takeaway is that first aid emphasis on pain management may be less central than rapid transport and monitoring for systemic effects when bites occur. Watch for comparative studies that test whether the same pattern holds in viper species outside Europe. Understanding evolved molecular function leads naturally to engineered molecular function and separation technologies. KAIST engineers introduced angstrom-scale transport pathways into polymer matrices and measured separation performance against the concept of network completeness. The optimized membranes showed improved selectivity for hydrogen over larger gas molecules. The work clarifies how cross-link density and pathway uniformity jointly determine throughput and purity. Prototype modules are now being tested under industrial pressure and temperature conditions. Scale-up trials will assess long-term stability under continuous operation. Practical separation tools matter for resource management. MacEwan University's AgriLow system uses color changes read by phone cameras to report key nutrient levels at low cost. New virtual reality modules now train users on sampling protocols and result interpretation without on-site instructors. Pilot programs in multiple countries report reduced fertilizer misapplication after training. The platform aggregates anonymized readings to generate regional nutrient maps. Expansion will add modules for micronutrient detection and pH calibration. From field-level data collection, we close with a policy layer that affects many of the materials and chemicals already discussed. New limits on per- and polyfluoroalkyl substances took effect across European Union member states this week. The rules also tighten requirements for overall packaging recyclability and waste reduction targets. Manufacturers must now document substitution plans for restricted compounds in direct food contact materials. Enforcement will rely on existing national inspection systems rather than new centralized testing infrastructure. Industry groups have begun publishing compliance timelines for common barrier coatings. Keep an eye on how field-specific citation adjustments in the Nature analysis may influence reevaluations of other long-term scientific trend datasets in the coming months. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. SpaceX Daily, the daily companion for following SpaceX as a public company, from Starship to the stock ticker. Find every show free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.